Goedemorgen. We gaan verder met het presentatieprogramma, het congresprogramma. De volgende presentatie zal in het Engels zijn. Dus een goed moment om de Engelse taal een beetje bij te spijkeren. Buildings of the Future. En de subtitel is, die zal ik in het Nederlands doen. Een visie op een gezond, duurzaam en een optimale binnenruimte. Dat niet meer energie gebruikt dan strikt noodzakelijk. Deze presentatie zal worden gehouden door Ellen Jackson. Ellen, welcome here in the Netherlands, in Gorinchem, during the conference exhibition Convex, as we named that, Future Lighting. And as an evangelist for lighting, I think you are the right person to present here the future of technology and lighting. The stage is yours.
Thank you. Thank you. Actually, it's very nice to be here because at one point yesterday I thought this was a fictitious place that people were trying to send me to, because everybody I asked, where is Gorinchem? No idea what I was talking about. Actually, Kees has told me how to pronounce it about 20 times, and I Gorinchem or something. But even in Amsterdam, I was saying, which train do I get to Gorinchem? No idea. But it is very nice to be here, and actually it's quite unusual to be at a lighting fair, a purely lighting fair. That's the thing I was used to go to 20 years ago, but now it's light and building or light and HVAC or something. So welcome all you lighting people. Today I'm going to try and answer with your help what we believe to be some fundamental questions, and that is, why is the design of buildings right now and in the future so important? And we're going to look at our role in the design of indoor spaces, primarily indoor spaces, and answer the question why it is essential that we design healthy, intelligent, future-proof spaces for buildings to come. I think it's quite an important question to answer. I guess you do too. Okay, a question before I start. Help me out here. Who spent yesterday, if you can remember all the way back to yesterday, who spent more than 1 hour outside yesterday? Who spent more than 2 hours outside yesterday? Did anyone spend more than 3 hours outside yesterday? Okay, one person at the back there. You must be a farmer. But actually, I don't want to believe this is true, but statistically it is true that we spend 90% of our life indoors. And that's quite frightening. When I read this first, I really railed against it. I didn't want to believe that I would waste so much of my life being indoors. But if it is true, even if we only spent 50% of our life indoors, wouldn't it make sense that we design indoor spaces for people? We design indoor spaces to be healthy, optimized for whatever task, whatever activity we're doing. It makes sense to me, and I'm happy to say that we're going to see some examples of why it's actually happening. It makes sense to me that we build buildings for us. We design indoor spaces for us. So whatever task we're doing, whatever activity we're doing, that the indoor space is optimized, especially after COVID. So after COVID, people are coming back into the office, and they want to use the office for different reasons than they did before COVID. Before COVID, I used to pick up my bag and go and sit in the office all day. Now when I go to the office, it's for training, for collaboration, for having one-to-one sessions with people. I don't sit in London all day, every day now. So we have a different need. And actually, we don't have to guess how to design healthy indoor spaces. There's actually a well building standard. I don't know if you're familiar with the well building standard, but there used to be 10 concepts. So of course, having clean air to breathe, having access to water. If there's no gin around, water will do. Having access to nourishment, so we're working at peak levels. Light is just essential for light. Good flicker-free light at the right color temperature, right color rendering. Movement, being able to move around. Thermal comfort. We all know what it's like to be too hot, too cold, too humid when you're trying to work, and how that affects your productivity, your creativity. So getting that right. Sound. Now, I went to a design show in London last month, and I was amazed. Half the show was about sound. It was about how to manage sound in indoor spaces. I'd never come across it before, but it was really fantastic to see how we're managing that. Materials, of course, linked very much to light. I work with a lot of lighting designers, and if they've spent an absolute fortune on, say, granite for the foyer of a hotel, and then they get the wrong color rendering for the luminaires, it goes completely wrong. So lights are essential in that way. Mind and community about how we're engaging with each other in indoor spaces. And they added another concept called innovation. You get extra points for innovation. My key takeaway from this slide is that your clients and you do not need to be going for WELL certification to adopt this principle. Every indoor space we're designing can use these principles to be better places for us to spend time in. So my takeaway, our goal should be really to design every building, every indoor space. Think back to that slide. Every indoor space at concept design phase, as early as possible, we're thinking about air quality, humidity, temperature, sound, light, and how they're going to work together. And I'm an engineer by trade. I've been doing lighting for about 130 years, it seems so. But I really do have an engineering brain. So my engineering brain always goes to how are we going to optimize this space by bringing technology together. Lighting designers, interior designers, architects will go a different route, but my engineering brain goes that way. If our buildings are intelligent, then we can make them future-proof. And by future-proof, I mean that tenants change, owners change, usage changes in buildings, and we shouldn't be thinking about how the technology can be updated to manage those changes. If we use the right technological foundations, the right technology, as the usage changes, as the tenants change, the technology can adapt. It can optimize those spaces. So one year, the building might be used by a law firm in London. A couple of years later, it could be a kindergarten. I don't know. But the technology should be able to manage that change. And that's future-proofing your client's asset. Your building is an asset. It's really unfortunate when I meet clients who have put in technology into their building, and 10 years later, they're ripping it out and starting again because the tenant changed or because it's out of date. So future-proofing, that's what I mean by that. And making that happen means making a choice. We can choose to design buildings that are continuously monitoring the environment, that are continuously optimizing themselves. We can choose to design buildings that are sustainable, and we can choose to invest in the future. And we could choose to design buildings that use no more energy than is absolutely necessary. And it's never been more. I'm old enough to remember the energy crisis in the early 1980s. Now this is a different world. We have the technology to make sure that any building is using no more energy than is absolutely necessary. There are some instances where the building needs to use more energy. For example, working in London in 35-degree heat, which is unusual, the HVAC is pumping all day long. Of course, we need to use more energy. But in normal conditions, we need to optimize that energy consumption. And it's quite possible to do that now. We're not waiting for any technology. I don't need to make you any promises that in the future we can do this. We can actually do it now. It's just a matter of making that choice, using that WELL building standard, those principles, those concepts, and bringing them together with technology. And imagine walking into a building where every piece of technology is interacting and making your day better. I can tell you, and actually if you're interested, I can show you. I've been to buildings where they've adopted the WELL building standard and they've adopted technology, and they are amazing places to work. I can also tell you from experience that when people are now coming for job interviews, they're making their decisions based on the place they will work. Is it good for me to be here? Post-COVID, people's brains are wired differently. If they think your building isn't healthy, isn't optimized, isn't making their day better, they're going to go work somewhere else. Or even worse, they're going to work from home. There are people, I run a company, and there are people in my company I've never met. They were employed during COVID, and we've never managed to get them into the office. The way to get them into the office is to make the office a brilliant place to be. And that means using technology in the right way and design in the right way. And I'm really happy to say that even standards are being updated to make people more important, to put people at the very core. So DALI is now DALI 2, and that's been updated with what we call control devices. So it now includes color temperature, it includes the visible and non-visible lighting aspects. If you want to know more about that, I could talk all day about it. So that's been updated. The well building standard, it's worth adopting those 11 principles even if your clients aren't going for well certification. And the inspirationally entitled EN 12464-1, which some of my colleagues are fed up with me saying, so I wish they'd give it a name so I don't have to keep saying it. This has been updated. It's an 11-year-old standard. It's been updated now again to include visual and non-visual aspects of lighting, so that we can now get the visual part, so we can go about our daily business, but the non-visual part is all about well-being and how your body reacts to color temperature, light intensity, flicker, and those things. If you're interested, let the guys on the Helvar stand know, and we can give you a white paper that's an introduction to that. But anyone that is interested or has an interest in indoor lighting, take a look at that standard. It is actually really, really good. I know standards are boring usually, but it's worth looking at. I mentioned that I'm an engineer. Sorry about that. I started off life as an aerospace engineer on helicopters and ended up in lighting somehow. But my engineering brain always works in the same way, and I've had to retrain it. If you'd have asked me 5 years ago, how do I make a building intelligent? How do I make a building smart? My answer would have been, put smart stuff in it. Put intelligent stuff in it. It's easy. That's how engineers like me think. Actually, I've had to retrain thinking about the well standard. If we take this room, how am I going to use design and technology in this room, make it future-proof, so that if this room is used for different activities or different times, I can provide the visual and non-visual lighting to support human beings in this space. I need to think on the left-hand side first. What are the outcomes and benefits I'm looking in this space? It should be a fantastic user experience. It should be sustainable. It should be future-proof. And it should use no more energy than is absolutely necessary. That's the starting point. Then we go on to who is going to use the space for how long and for what activities, and how are we going to make sure that they have a healthy, prosperous time. How are we going to maintain this space so it's always working? And how are we going to use technology to do that? How are we going to get people to come here and really enjoy this space? And then, only then, do I choose the technology to unlock those outcomes and benefits in user experience, rather than my old way of thinking, which is, here's my technology, please buy it, and I promise you those things. So it's just a different way, and that's what EN 12464-1 teaches you. It's the order of thinking. So it really starts off in the first chapter, human beings first, then the technology, and we should not compromise on the technology to the detriment of the human beings. So well worth taking a look at that standard. As I mentioned, so technology choice is important. It's important because it's the way that we can unlock our indoor spaces. It's a way that we can constantly monitor those indoor spaces so they're always optimized. And it means technology should be connected. It means we should be connected to the technology. And we have more choice than ever. Now I'm getting a little bit more technical, but this is as technical as I'm going to get. That we have choice of wired solutions, we have choice of wireless solutions. We can even build indoor spaces that use a mixture of wired and wireless. There's no compromise to make. We can make those choices. So the choices are there. But I can tell you something. I work for a company called Helvar. We have a small stand outside. It's very nice. 90% of our design and technology investment is going into wireless. Wireless is the future. Sure, wired systems are great, and That's my background. But wireless is obviously where the future is going. It's quite incredible to think that with wireless technology, any building can be brought up to the standard of the most modern building in the world. There's no infrastructure changes, there's no ripping cables out. Any building in the world can now be brought up to the same technology as the most technological building in the world by using wireless technology. And that's what we're now starting to see in London, for example, where I'm from. All of the law firms have moved out, literally all of them. All of the banks have moved out. So these buildings are empty. So now they have to figure out what are these buildings for. So now they're being used for temporary workplaces, training facilities, etc., etc. So now we have these fast fit-outs. I want to hire this building, I want to hire this room, and I need it in 3 months. So we can use wireless technology to achieve that. Another important aspect, whether you're choosing wired or wireless, is understanding how your space is being used. If you don't understand how the space is being used, you can't optimize it. And the key to optimizing any indoor space is sensors, sensing technology. So sensing, as well as providing automation, can provide you with really detailed descriptions of how any indoor space is being used. And there are 4 basic steps in any sensing, any indoor environment. The first step on the left-hand side, if you want to understand what's happening in a space, you need a sensor. Once you've got that sensor in place, let's say, for example, it's a lighting sensor using DALI. That sensor is generally switching the lights on and off so that you're using no more energy than is absolutely necessary, and dimming the lights up and down, depending on ambient light conditions. But these are digital sensors, so we can get occupancy data from sensors that are already doing a job. Once we have that data, we can refine it, we can create value from that data. The best way to create value from data is to share it with the other building services. If you remember back to the well-being standard slide, so we had temperature, humidity, light, and all those other aspects. We can start to join them together and share the data. For example, we do a lot of design for universities. So they're using the data from the lighting sensors and sharing it with the HVAC guys. So the HVAC energy consumption is now based on ambient conditions, time of day, and human behavior, how spaces are being used. And some of the figures we're getting back now, for example, from Bristol University, they're reducing their HVAC energy consumption by 45%, just by using the occupancy data from the sensors in the different spaces. So it's about thinking at how those different well-being standard concepts are working together. And you'll be very familiar with sensors, lighting sensors. So for example, this is a typical lighting sensor. It goes in the ceiling, and it's doing a job. It's switching the lights on when the space is occupied. It's switching the lights off when the space is vacated. It's dimming the lights up and down to keep a certain lux level, maybe in an office environment, 600 lux on the working plane, depending on ambient conditions. And that's great. That's what we're used to doing. And if I look and tie that to the well building standard, we get some points for the lighting part. But we said we were innovating and going wireless and putting more money into the wireless than wired. And what that means is really taking advantage of that well building standard to understand more about the indoor environment. So if we think about, it didn't come out too well on here, but that's supposed to be an office. If we think about a typical installation, let's take the building we're in right now. I've never been here before, but I can guess that there's some sensors around the building that are on the BMS, the building management system, for HVAC. And they're monitoring maybe temperature, humidity, TVOCs, CO2, other things. Probably there are sensors around the building doing that. There may be some standalone sensors, maybe in this room, maybe on the wall by the door, that are measuring the similar ambient conditions. I bet there are quite a few lighting sensors around. Certainly in an office environment, they are the most densely populated sensors in a building. It's even in the UK and other countries, it's now legislation that you need to have sensors to switch the lights off when the space is not occupied. What we find, we've done our own studies on this, is lighting sensors are the most common sensors in a building. If you go to any office building anywhere in Europe and Asia. So it made sense to us at least, to now combine the lighting sensors with the indoor air quality and environmental sensors and use the same platform, whether it's wired or wireless, to carry that data. It also means that we have an upgrade path. If you can use the existing lighting networks and upgrade them to include indoor air quality, then we get a better understanding of the spaces that we're working in and a more optimized environment. On a new build, it also reduces installation costs, it reduces embodied carbon, and it creates a network, an easy network. So this is where the innovation is coming. It's how to bring those well-being concepts together, get them working interactively, get them working together to provide really optimized indoor spaces, and use the technology sensibly. Why do we need 3, 4, 5 different sensors on 3, 4, 5 different networks when we can just use the lighting network to provide all of those different bits of data? So just a different way. And again, the Helvar stand just out there on the right-hand side, we've actually got a setup where we can show you this if you're interested. But it's quite a good innovation and quite interesting for upgrading existing installations and for new builds. So what we then see is we can use our lighting sensors not only to provide the functions that we require for the lighting installations, but also now to measure temperature, humidity, noise, and air quality. But the key is now we can get them working interactively. And remember, optimizing that space means understanding how it's being used. So now we can start to think, okay, what was the air quality, the thermal comfort, the sound compared to occupancy? So how is the occupancy affecting the other building services, and how can we optimize the other building services based on occupancy? And all of this data is now working together and interactively. Why is that important? We are bleeding emissions in buildings. I live in London, and I walk around, and I see, like in Canary Wharf, lights on 24 hours a day. Which means probably the HVAC is working 24 hours a day. Those buildings are bleeding emissions. They're bleeding energy consumption. And from a technological perspective, we're not going to stop that. It's almost impossible to stop that, but we can slow it down. And how we slow it down is by utilizing that sensing technology and capturing data, getting insights about how our indoor spaces are being used, and closing what I've now started to refer to as the energy gap, the performance gap. What that means is there's a recent study by RIBA. RIBA is the Royal Institute of British Architects, and they use a 7-stage model for the design of buildings, and it's quite an interesting model to follow. What they've done is they've now published some figures on a website called carbonbuzz.org, if you want to go there. So the figures are published by RIBA and then supported by BREEAM and LEED. What they're showing us is that buildings generally use between 2 and 5 times more energy in their operational phase compared to their design phase. That's not because the design phase was rubbish or nobody knew what they were doing. It's just that things change from the design phase to the operational phase. Maybe the tenant is different. Maybe the owner is different. Of course, the energy prices are going to be different. So what we're trying to do now is just make this visible to people and say, hey, look, you're doing your best with the design, but the operational phase is not right. You know, we're trying to design with LEED and BREEAM with the best of intentions at one stage, and then 2 years later during the operational phase, everybody's getting a fright because some buildings are using 5 times more energy. And people are now starting to publish their projects on this website, so the likes of AECOM, WSP, Landsec, British Land, those are now saying, yeah, we're experiencing the same thing. And acknowledgement is one step towards making it better. So we're now acknowledging that this is the case, And the way to make that difference is to, as I said earlier, utilize sensors, understand how the space is being used, collect the data, refine the data, and create value from that data. And the value is creating insights about how the space is being used, getting occupancy insights, what's being used, what's not being used, and keeping the building really working at optimal levels. We don't want any downtime in our buildings so that the asset is wasted. So data is a valuable commodity. I know this is a busy slide, but we have one project, we have many projects, but this is a project in Finland called Jyväskylä Hospital. The client wanted to know at every part of their asset, their building, how the spaces were being used. Each of these heat maps is a simple lighting sensor. So the lighting sensor is a DALI lighting sensor, and it's measuring the occupancy every 30 seconds. So the more that occupancy sensor is triggered, the warmer the heat map. So the client was very, very happy. They can now get a visual representation of their building using lighting sensors with no additional investment required for any other technology. Actually, 1 year after they were using the building, it became clear that what was the most interesting data were the spaces that weren't being used. So they were able to look at their simple heat map, look at spaces and say, well, actually, do you know what? There are spaces in our buildings that are never used. That's a waste of resource. That's a waste for their asset. And now they can start to look at why are they never used? Is it too cold, too hot? Generally, the answer is there's no natural daylight. People don't like to hang around in places where there's no natural daylight. So some of these areas where there's no actual daylight, they're now upgrading from DALI Type 6 luminaires to DALI Type 8 luminaires, so they can provide intensity control and color temperature control. And hopefully that investment pays off, and they can now get people to start using these spaces where there's no natural daylight. It's the same in our office. If you walked into our office in London, there's a bunch of people sitting at one end and a bunch of people sitting at the other end, not because they don't like each other, because that's where the natural daylight is. So we're now upgrading our office in London to have DALI Type 8 luminaires in the middle and DALI Type 6 luminaires at the end. So again, utilizing technology to make that a better indoor space. Again, once we have data, we can start to analyze it and create insights. So again, you can see a practical demonstration outside if you're interested. This is a readout from our office. No, it's actually Jyväskylä Hospital again. So they can now start to see occupancy in different areas. So this is the whole hospital, but you can then drill down into different parts of the hospital by groups and start to see how is it being used, how is it not being used. What we're finding is that most office spaces these days, post-COVID, have a 40% occupancy rate. According to figures out by REBA, 75% occupancy rate is healthy. So if your employees are coming into the office 75% of their time, that's a healthy ratio. 40% of their time is not a healthy ratio, for obvious reasons. So we can now start to look at this and say, well, how are we going to get this up? And actually what we've learned is go back to the well building standard and provide a really fantastic place for people to come to, and they will come to it. I do a lot of seminars, traveling around. I'm very lucky to do my job. But when I go into some offices, they are packed full of employees, and I can guarantee those offices have adopted the principles of the WELL standard and provided those employees with fantastic working conditions. When I go to do some seminars in offices that are empty, it's obvious why they're empty. Really obvious. I mentioned earlier on about using the lighting platform to combine those WELL building standard concepts. And once you've done that, you can actually start then to map occupancy against air quality, humidity, temperature, CO2, TVOCs, that kind of thing, indoor air quality. And it's a very interesting insight of occupancy versus air quality. You would think that air quality goes down when occupancy goes up. It does if you don't have a very good indoor air quality system or you don't understand the data. So these insights can really tell you something. Well worth having a look. But at the end of the day, the big finish now, our goal is to create sustainable, amazing indoor spaces. I'm all for having amazing indoor spaces, just not average ones. It's about providing a great user experience. It's about having buildings that use, again, I've said it 4 times now, use no more energy than is absolutely necessary. We can't continue to bleed emissions from our buildings just by not making the right technology choices. And something else I might have mentioned a couple of times, future-proofing those buildings by making the right choices of technology. That's absolutely key. Outside, I've seen some fantastic technology. There's more technology than we need, wired or wireless or hybrid. But it's getting our clients to make that choice and understand the benefit of making that choice. So, what is the building of the future? From my perspective, hopefully a little bit yours now, it's about making that right technology choice to future-proof those buildings and not leaving it to future generations. Again, this is the 6th time, making the technology choices and using those interactive technologies to make sure that the building doesn't use more energy than it absolutely needs to. You might think this is what we now call greenwashing, or bullshit, as it's sometimes known. But certainly not in my lifetime. I have 2 children. Maybe not in their lifetime. Maybe in my grandchildren's lifetime. It's going to come. People are going to start saying, I want my building to be carbon neutral and energy positive. My colleague Lars and I were in Norway a few weeks ago, and we were challenged on this by the people in the room, is how do we get there? In London, there are now 3 buildings that are classified as carbon neutral and energy positive. Is it expensive to achieve? Yes. But if we strive towards it, then it will become a reality. So certainly maybe in my grandchildren's lifetime, this will become a reality. I truly believe it will. But actually, what I believe is true now, when we look at the standards, DALI 2, Well Building Standard, EN 12464, that people are being put at the very core of our indoor designs for lighting, heating, ventilation, indoor air quality, those types of things. If you remember back to that slide, start with the outcomes and benefits, then go on to the user experience, and then think about the technology, but always put people first. How is the space going to be used, by who, when, for how long, and how are we going to future-proof it for other people who might use this space? Which means I'm handing it over to you, that if anything sticks today, then go and tell the world that people should be at the very core. Go out and challenge us. Go out and challenge the people outside. That how does your technology put people first? How does it benefit the users of the space? If they can't tell you, go to the next stand, and the next one, and the next one, because that's what employees are doing, and that's what people who are coming to work for us are doing. They're coming to our office and saying, how does your indoor space benefit me and make me more creative, more productive, and how am I going to have a great time here? So it's now your problem, not mine. Cool. Thank you for listening. Thanks a lot.
Alan, thank you very much. It's quite a clear presentation you had.
Thanks.
And I think interacting is key in this. Know what you are doing and interacting with the surrounding of your place you are working in. And talking about interacting, questions here in the room. Heeft u vragen?
Hi, thank you for the presentation. I have a question about one slide where you presented 3 reference offices.
Yep.
And the design indicated a certain amount of energy needed for the building.
Yep.
And the reality showed up to 5 times more energy.
Yeah.
Can you elaborate a bit on where this energy is
I've got a more detailed slide, but it's a bit difficult to see. But there's a website called carbonbuzz.org, if you want to have a look at it. And what some companies have done, like AECOM, Landsec, British Land, etc., they've broken down the energy consumption during the operational phase of their building. So not only lighting, but HVAC and other building services. And they've compared that to the original lead and BREEAM and design phase. And it's true, the data shows that the original design was here, and the outcomes were here 2 to 5 times more. And the biggest culprits of that are lighting and HVAC. So they're the ones that people are getting, wrong in that phase. And again, it's not because the design was wrong, it's because the usage is wrong. Or, for example, I'm sorry to say, that sometimes the contractors take out the technology to save a little bit of money, and the lights aren't being switched off automatically. That's a problem. So the design phase may have had, for example, automated lighting, but then the contractor or somebody has decided to take that automated lighting technology out to save some money, so that now the lights are staying on when they shouldn't be. But if you're interested, the website is called carbonbuzz.org. It's not run by me, it's run by REBA and BREEAM. Thank you for the question.
Zijn er nog meer vragen? Die zijn er.
Thank you very much for a very interesting presentation.
Hi.
You say, well, let's put people first in our buildings.
Yep.
I can understand from your engineering self, this can be understood as a building that has very good controls, where everything is controlled very well. On the other hand, people like to be in control of their personal environment. Mm-hmm. How can you, reflect on that? Building control against, or actually automatic control against personal control.
Yeah, it's a really interesting topic, actually. If I give you an example, we did a upgrade, or it was the Louis Poulsen headquarters in Copenhagen, a beautiful building. And the technology chief there, Kasper Hammer, wanted a really automated lighting system with circadian lighting. He wanted to replicate as much as he could the natural environment indoors. So over a 3-month period, he engaged with every employee to ask them every single day what they thought about the circadian lighting rhythms. And he put 4 different rhythms in place and told the employees every time he was changing it. So sometimes they would keep the color temperature the same and change the intensity. Sometimes they would keep the intensity and change the color temperature. Sometimes they would give them a blue boost in the morning and then a really natural circadian rhythm during the day. And everybody had an opinion, but he could never get it perfect until he gave everybody a desk lamp. Once he gave everybody control of their own environment, everybody was happy. So control is actually essential. Everybody wants to feel as though they're in control of their environment. And that's what connectivity is about. It's not only about the building services being connected, it's somehow we need to be connected to the building. And the technology is there. Everything I own is Bluetooth enabled, for example. My laptop, my phone, my iPad, my watch, is all Bluetooth enabled. There's no reason why the room shouldn't know that I'm in the room and then optimize it for me. And then you just need clever algorithms if there's bunches of people in the room. So if 10 people are in the room, knowing what their preferences are, and there are some customers already doing that. There's a great company called HB Revis. You may have come across them, a Slovakian company, who are utilizing technology in all of their buildings to get WELL Platinum and LEED or BREEAM highest standard. And if you go into their building, each room is optimized using data that is gathered from everybody in the space, and you can do it from, they have a pin that you can wear, from a wearable, from your device, from anything. So that control element is absolutely key to getting it right.
Thank you very much.
All right, thanks.
I have another question about sunscreen control, because you didn't mention that.
No.
Although having very much interest in integrative lighting, mm-hmm. and the fact that HVAC is also related to that, and lighting conditions, what are the possibilities here?
Can you just repeat the beginning part?
Well, it's about sunscreen control.
Right.
It was not mentioned.
Yeah. The use of natural daylight is absolutely essential. So, for example, we've just finished one project in Edinburgh, which is in Scotland. There are 3 buildings, and they're circular buildings with glass all the way around. We're using Dali Type 6 luminaires, because there's loads of natural daylight on the periphery, and then Dali Type 8 luminaires in the beginning. The control of natural daylight in that building is non-existent. Just is. That's the design. Whereas, for example, if you went to the World Trade Center in Abu Dhabi, which is another of our projects, we have automated shading. So as the sun comes round, the shades are automating. They're going up and down and tilting so that we're making full use of natural daylight. And then we're modifying the ambient conditions within the building using our lighting sensors.
Yes, but it's also about the finding the balance between energy consumption and heat control.
Yep.
And on the other side, having the control of daylight admittance, and so having a perfect lighting condition for the employees. So that's the whole deal. And I was just wondering, because it wasn't mentioned.
Yeah, I had 30 minutes. I could talk all day.
Okay, no problem. We can discuss that later.
But the utilization, I mean, we throw around a term in lighting called daylight harvesting. One of the first things I learned in lighting was daylight harvesting. And then we talk about daylight linking.
Yeah.
So daylight linking is kind of a forgotten art, in my opinion, is everybody talks about harvesting daylight, but very few people talking about daylight linking, which is linking that daylight to other building services. And that's what we're trying to regenerate here, is get people thinking about that.
Really get more attention, that's for sure.
Yeah. But thanks, good question.
Thank you. Other questions?
If not, our pop-up later. You can meet Ellen at the booth of Helvar, but otherwise at the meeting point at... I do it in Dutch. And
I'm hanging around in Gorinchem.
You're walking around in Gorinchem? Okay.
Gorinchem or whatever.
Okay, it's typical Gorinchem. So, als u nog meer vragen heeft, de stand van Helvar kunt u terecht. U kunt ook terecht om op de stand van GroenLinks Vlaanderen en NSV om hem daar te ontmoeten. Ellen, thank you very much for sharing your knowledge. We have a kind of souvenir from the Netherlands for you.
Oh.
And I hope to see you back more and more about this very interesting topics.
Thanks a lot.
Thank you very much.
Thank you.
See you, bye.